Today we will be talking about a very important event in the history of Earth, that is the Cretaceous tertiary mass extinction. Mass extinction, let me tell you the meaning of this term. Mass extinction, the death of a particular animal is not termed as extinction. Why? Because the animals, they usually leave their offsprings. So, if the individual does not survive, the offspring survive, the lineage moves on with time, and such lineages which moves on with time, they are not called as extinct even when the organisms or the individuals die intermittently. The extinction comes into being when a particular group of organisms, they die and they do not have any survivors left on earth, and then they do not even return in the coming time. Hence, I told you that the extinction is usually understood in terms of the permanent disappearance of a particular taxa from earth for no time to come in the geological usually records. There have been periods in the earth's history in which not only one group, rather several groups of the organisms, they became permanently extinct. And such extinction events in which many groups are involved are called as mass extinction. The greatest mass extinction which is recorded so far by the geologists is the Permian Triassic mass extinction that occurred at the boundary of the two eras, that is Paleozoic and Mesozoic. The end of the Paleozoic is Permian and the start of the Mesozoic is Triassic. So, it is the Permian Triassic boundary which is defined on the basis of the mass extinction, where 95% of the marine form, they became extinct. The second largest mass extinction, which has affected the land fauna predominantly, that is called as the Cretaceous tertiary mass extinction, and that is another boundary of the two eras, that is Mesozoic and Cenozoic. Thus, we see that the eras, they end at some very important paleontological events that happens in the earth's history. Today, we will be talking about the Cretaceous tertiary mass extinction. The end of the Mesozoic is Cretaceous and the end of the Cretaceous is the Maastrichtian time. The start of the Cenozoic is Paleocene and the start of the Paleocene is Danian. That means, if you talk about the precise timing, so that will be called as 65 million years or the Maastrichtian Danian boundary. Cretaceous tertiary mass extinctions have been now renamed as Cretaceous Palaeogene mass extinction, KPG mass extinction. And this particular event, that is known to the common people also. Why? Because a very giant form of the reptiles called as dinosaurs, they became extinct, and these dinosaurs, they are very well known forms which was affected by this event permanently. But not only reptiles like the dinosaurs, but some other forms also became extinct. If you talk about the faunal extinctions, so we see the extinction of ammonoids permanently, which are mollusks, the extinction of the belemnoids permanently, which are also mollusks with endoskeleton. We could see the extinction of the inoceramids, which are also mollusks, but lamellibranchs. We could see permanent extinction of the rudistid bivalves. These rudistid bivalves are also lamellibranchs. As far as the floral elements are concerned, the cycads also became permanently extinct. The monocots, which was very insignificant in the Mesozoic, they diversified into the Cenozoic, and dicots, which are also angiosperms with two cotyledons, they also became diversified into the Cenozoic. So, the gymnosperms, they became extinct, and the angiosperms, they flourished. As far as the microfossils are concerned, so Globotruncana, that is a very successful form into the Mesozoic, they also became extinct at the end of the Mesozoic. And Globorotalia became a very successful survivor into the Cenozoic. Rugoglobigerinids also, they became extinct at the end of the Cretaceous or at the end of the Mesozoic. So, we see that there are many different forms which was variously affected by this event. As far as the global tectonic events are concerned, so that particular boundary has witnessed the end of the Laramide orogeny and the start of the Alpine orogeny. So, a very conspicuous change in the tectonic regime as well. So, tectonic events have seen some drastic changes, the paleontological events have seen some drastic changes, and the sedimentary facies also changed. The climate was also warm, it is much warmer than now in the end Cretaceous time. We usually blame many things for the climate change, but there were times when the temperature of Earth was much higher than what we have now and much lower than what we have now. Hence, many of the constraints we usually understand that changes the Earth's physiography, or it brings out some physicochemical changes in the Earth's atmosphere, they have to be first understood with all the constraints applied. Then let us talk about the sections which are preserving the Cretaceous tertiary boundary extinctions. So, Tunisia is a section which is considered to be the type section of the Cretaceous tertiary boundary. Apart from that, we have Gubbio section in Italy and Zumaya section in Spain. So, these are the international stratigraphical sections which are usually considered to be the best exposures of the KT boundary. In India, we have the KT boundary best exposed at Shillong Plateau, where we have two different formations exposed. The basal is Mahadek, the upper one is Langpar. So, Langpar formation is Cenozoic, that is Palaeogene, and the as far as the Mahadek formation is concerned. So, upper part of the Mahadek has the layer in which the lower portion of that upper part is it shows the paleontological assemblage typical of the end Cretaceous, and the upper part of the top portion of the Mahadek shows the first appearance of the Cenozoic forms. So, it is in the Mahadek formation that the Cretaceous tertiary boundary lies. We will be seeing these details of the formations very soon. Basically, the study of the different stratigraphical sections and the assignment of a particular layer as the KT boundary has a lot of constraints to be understood. The first constraint is that the everywhere this event is noticed. In all the KT boundary sections, we have the Mesozoic forms, they decline and disappear at this boundary or close to this boundary, and the entire new biodiversity appear as we cross this boundary. So, apart from these sudden or subtle paleontological changes, we also find the changes which is in the geochemistry part as well. Actually, there is a siderophile element which is called as iridium. Now, the question comes, what is a siderophile element? Sidro means iron, phile means loving, iron loving element. Actually, we do have different kinds of elements which like to live in different regimes. Iridium is a siderophile element, so it prefers to live in the mantle which is iron rich. And since the earth is layered, after the earth forms, it after the formation of Earth, it has undergone vertical differentiation into the crust, mantle and core. The crust contains the lightest of the elements, the mantle contains little heavier element than the crust, and the core contains heaviest of the elements. So, these elements that was uniformly present initially on the Earth has undergone vertical differentiation into the lightest and then heavier and the heaviest right at the center, that is at the core. So, we do have the elements which are concentrated in the mantle, and they usually very rarely they come up on the surface through some volcanic eruption or some other events. So, this is iridium, which is basically a siderophile element. So, the presence of the anomalous iridium in a particularly defined layer, which is few millimeters to a few centimeters thick in every sections worldwide, then it offers you two different kinds of assumptions to make up. The first assumption that it offers is that it was brought by some meteoritic impact, and second, that some volcanic eruptions might increase, because the extent to which we find iridium into those layers is usually not found on the crust. So, through the usual deposition of the sediments on the Earth's crust, it is not possible to increase the content of iridium so much. Then we are left with only two possibilities for such a kind of a different concentration. One is the as I told you, the impact of the asteroid on the Earth, and the second is the volcanic eruption. Both the events are catastrophic for the life. Even if we have the huge volcanic eruptions everywhere on the surface of Earth, that would lead to many of the biodiversities totally disrupted by these events. And if we take the other possibility into account, that means if a meteorite of the worth, say the size of the 8 kilometers or something, that hits the Earth's surface, you don't have anything that would left. Actually, when a big space rock that enters into the atmosphere of this planet, this is usually something like it passes through the air, and as the friction of the air mixes with the high velocity of that space rock, so that catches fire, and as it catches fire, it becomes in the form of a tailed comet like object, and when it hits the Earth's surface, it vaporizes. But before it vaporizes, it gives all the impact as a solid body onto the particular Earth's surface, and then it cracks. And this particular event can create smoke and dust and cloud, so much so that it will mask the entire atmosphere, and ultimately or eventually it will block the sunshine. As it blocks the sunshine, no photosynthesis will be possible on the Earth's surface, because without light, the food in the ecosystem is impossible to be prepared. And if this happens for a couple of months, then the primary productivity would be lost, and this would lead to a gradual cascade of events that would change the ecosystem or the food web or the food chain, and after some time you will find the gradual extinction of the individual forms of life. So, this is one way in which the Cretaceous tertiary mass extinctions could have occurred. And additionally, it also adds some of the elements to the Earth's surface, which is usually not found by that amount, iridium for example. So, iridium rich anomalies, which are usually found into every KT boundary section, is attached with the extraterrestrial mechanism. However, there is one school of thought that combines this with the earthbound mechanism also. So, we will be discussing this at the later part of this discussion, but let me tell you how to identify the Cretaceous tertiary boundary based on the paleontological record. There are two ways in which this can be done. The first way is that the disappearance of all the Mesozoic forms is to be taken as one parameter, and the appearance of the first Cenozoic form is taken as another parameter. But both the parameters are preserved into the single stratigraphical record is something which is quite unnatural to think. But in some of the sections, some of the best preserved sections, both these events are recorded into the single stratigraphical section. There is a form of planktonic foraminifera which is called as Abathum phalasmia orensis. This particular form tells you the end of the Cretaceous. That means, wherever you get this particular form, this marks the latest time of the Mesozoic or the Cretaceous, and that is what you call as Maastrichtian. So, the marker of the Maastrichtian is Abathum phalasmia orensis. Then Gumbelitria cretaceae, that is another form of foraminifera, which marks the earliest layer of Danian. Danian is in Cenozoic. That means, the first appearance of the Gumbelitria cretaceae and the last appearance of the Abathum phalasmia orensis is taken as the boundary between Cretaceous and Tertiary, and this has been taken as the boundaries worldwide. You can ask me a question, what if these forms are absent and some other forms are present? Yes, this is quite possible, because the biozones are not exactly tallied. Why they are not tallied? The reason for this is provincialism. What is provincialism? Provincialism is that I am an Indian, I live in Indian subcontinent, I have my own form and face. An African is also Homo sapiens, but it is different than me in appearance. A Chinese that lives in China has a different appearance. A man from US and a man from UK and a man from Australia. These are all Homo sapiens, humans like me and you, but they have different forms, they have different appearances. So, that means in nature the flora and fauna exist according to their own geographical constraints. So, this geographical constraints which is manifested as different morphological feature of that particular organism or form is called as provincialism. So, because this provincialism is a natural instinct that occurs not only in humans, but in other organisms or other animals as well. So, because of this provincialism, you cannot assign a particular taxa, as I told you that it is Abathum phalasmia orensis only occurring in one section is more suitably found in the sections elsewhere as well. And if there are some other forms that exist, it has to be correlated in age to the Abathum phalasmia orensis. Like we do have the Micula princei. Micula princei is a kind of a coccolith, and that shares an age common, and hence you can take both as the latest Cretaceous representatives. So, if we do have Micula princei in one section and Abathum phalasmia orensis in the other section, both can be taken as the end of the Cretaceous or end of the Maastrichtian period. Now, similar is the case with the start of the Paleocene or the base of the Danian. So, these boundaries are defined by similar or correlatable paleontological groups in some other sections. The best stratotype, as I told you, that is in Tunisia. In India, we do have in the Shillong Plateau, and this Shillong Plateau exposes two formations, Mahadek formation and Langpar formation. Mahadek formation is older and Langpar formation is younger. The Mahadek formation it contains the calcareous silty layers, and these calcareous silty layers are overlain by the 1.5 centimeters thick layer of iron. That means 1.5 centimeters thick ferruginous layers overlie this, and then we do have a succession or a sequence of ferruginous brownish colored, blackish colored shales. So, I mean lithologically these layers, they are less different, but they are different. But what is more different is the presence of the fossils. That means there is high difference in terms of the biostratigraphy or paleontology, and less difference in terms of their own lithological appearances. However, worldwide there have been changes across these boundaries into the sedimentary facies that appear. Then as far as the paleontological groups are concerned, which have been reported from the Katy boundary. So, Katy boundary is placed within the Mahadek formation and in the upper part of the Mahadek formation. So, the lower portion of the upper part of the Mahadek, it contains many of the forms which are typical of the latest Cretaceous fauna, like Globotroncana, like Rotoglobigerina, different species of that which characterizes the end of the mass extinction, Globotroncana species, especially Globotroncana stuarti. So, these are the species which are planktonic foraminifera, and they characterize us as index fossils of the late Cretaceous, latest Cretaceous. Then across this boundary, we do have the Gumbelotria cretaceae appeared for the first time, and that marks the base of the Dannean. And in between these two occurrences, we do have an iridium rich layer, and this iridium rich layer, it marks the ferruginous band, and that occurs at the boundary of the last appearance of the Cretaceous forms and the first appearance of the tertiary forms. But we see that these different forms in different sections worldwide, they are not exactly related, and they are not exactly tallied with each other. The extinctions occur in different capacities, in different amounts, and at different times at different places. But everything happened within a span of 2,000,000 years. That means this is a 2,000,000 years is not a big span of time as far as the geological time scale is concerned. So, within this short period of time, there were subtle changes in space time in the earth. So, different organisms, they became extinct at different times. Hence, such events are often termed as time transgressive. Time transgressive, to understand time transgressiveness into the simple terms, that if you want to tear a paper, you cannot tear both the ends of the paper at the same time. If you are tearing a paper, you have to tear starting from a beginning, and then it will propagate in few seconds to the end of that paper. So, this is time transgressiveness. That means, time transgressiveness defines different parts of the paper being torn out at different times. So, this is an analogy which can be applied to the mass extinction events and breaking of the continent. So, this and the transgression occurring onto the land, regressions occurring. Well, this reminds me one thing which I forgot to discuss, is that there was a contrastingly lowering of the sea level at this particular boundary. There are many changes. I have talked about the tectonic changes, I have talked about the changes in the sedimentary facies, the paleontological changes, the changes in the geochemistry, especially in the iridium rich anomaly layers. And then there was the changes in the sea level bathymetry also. At the Cretaceous tertiary boundary, the sea level was lowered. What lowering of the sea level has to do with the extinction? If the sea level will be lowered, many of the portions that was drawn in the sea would be exposed to the land. And then the ecological system of many of the groups of the shallow marine forms that will be lost, and this might form one of the reasons why they became extinct. This tells you about the global correlation with the Indian succession, and then comes the two different mechanisms which are thought to govern the Cretaceous boundary or end Cretaceous mass extinction. One is the extraterrestrial mechanism, the other is the earthbound mechanism. Extraterrestrial mechanism, as I told you, is something that supports the showering of the meteorites on the Earth's surface, that is reflected in the form of iridium rich anomaly, and that has wiped out many of the life forms for no time to come back with such mass extinction. However, we will have to admit at this point that this mass extinction has affected mostly the continental parts. It has affected less the marine parts, but nevertheless the marine parts is also considerably affected. The second school of thought is also quite logical in its form, and that school of thought believes that such extinctions, extinction is a geological event. So, and the hitting of the earth by a meteorite is a relatively rapid event, and this rapid event will not let, it might kill some organisms individually, but as far as their extinction permanently is concerned, these short term events cannot lead to the long term changes in the paleontological record. So, the two events do not match accurately. In order to understand the extinction as a gradual cause, the earthbound mechanism has to be accepted. So, the second school of thought, it is adhered to the earthbound mechanisms. In 1983, in the Hawaii Islands, Mount Kilauea had some volcanic eruptions, and these volcanic eruptions, they brought very anomalously higher iridium. Because this volcanic eruption was limited in extent, so this iridium did not kill many of the forms, and it did not brought any significant geochemical changes on the Earth's surface. But it tells you one thing, that if you have the iridium anomaly by the volcanic explosion, and that we could see in our lifetimes, that means this also can be one of the reasons why we have the iridium anomalous rich layers often with time to time. Then this increase in the, and at that same time, even in India, we had the huge flood basalts called as Deccan traps. So, Deccan traps also represent the huge volcanism, and there were many volcanisms at the close to the Cretaceous tertiary boundary. So, these volcanisms have been considered as one reason why the iridium anomaly occurs on the sediments. And then the second reason of the extinction, mass extinction, is the changes in the chemistry of the oceans, the dissolution of the shells. And if you put a marine organism that survives into the higher salinity, is suddenly put in the freshwater regime. So, the change in the salinity of the water also might lead to the extinctions of the many organisms. So, there are many events which are related to the earth, which are related to the events outside the earth, and both these events can be thought of working probably in a combined manner, instead of the fact that they have worked separately, and only one of that is responsible, is something which is unwise to expect. I have tried my best to give you the insight into the Cretaceous tertiary boundary through paleontological and other related discussions. I hope you have understood and enjoyed this discussion. We will be discussing more interesting topics in the lectures to come. Till then, thank you very much.